So hello, my name is John Reedy from the HGF group, and today we're going to do a demo install of HSDS Server for Azure Marketplace. So HSDS is a server application that lets you access HDF content that's stored in Azure Blob Storage. And this has many advantages over using disk drives, namely that you can have multiple clients accessing, you're not constrained to the amount of storage you use, you pay for what you use, and the cost is generally less than you pay for disk storage. So to get started, we'll go to azuremarketplace.microsoft.com. And this is a site that lists many add-on products for Azure Marketplace. And we'll search for HDF. And we see no feedback right now. We see HSDS Azure VM. You can also install HSDS on Azure Kubernetes, but we don't have a guided install for that. And in general, though HSDS is an open source product, by going through a marketplace, you have a much more smooth experience as far as setting up the server, as we'll see. So we click on this and some general information about the product, and you click Get It Now. And say Continue. And as we speak, we're going to the Azure portal and setting up the Azure VM. So this will have a preset image that contains all the software we need to get started. So we need to select a resource group. So let's make a new one called HSDS Demo. And I'll use that for the server name as well. Let's do US 2, so I'm near there. I think all the others should be fine. Generate new key pair. And then we go on to disk. So the server doesn't require any specific disk storage, so we can just keep on going. And then this is network interface. We'll just accept defaults for here. Management diagnostics, defaults are fine. Advanced is fine. Tags is fine. So now I go through and create. So the Azure will be creating a new virtual machine, which will be running our server. I guess first it validates the parameters, and then it's going to have a create. So we do create. And you need a key pair for any users who will be logging on to the server. And that's typically only the admin would require that. So download this key pair. And meanwhile, the creation is getting deployed. Meanwhile, while that's happening, I can just talk a little bit about how the server is architected. So it runs as a set of containers. And there are multiple containers, and they're used to enhance performance. So basically, when requests come to the server, they can get parallelized across these multiple data nodes. And the data nodes basically partition the object store space so that each data node owns a partition. And thus, when you are accessing certain selections of HDF data sets, you can have all the data nodes accessing data simultaneously. And that basically means you're utilizing all the cores on your machine and taking full advantage of network bandwidth. So larger machines mean that you will have ability to have more data nodes running and better performance. On the other hand, it'll cost more because it's a larger machine. Okay, so meanwhile, our server is created. If we go here, we see it's running. Now, it doesn't actually run the server until you go and configure it for your uh, settings that are specific to your organization. So let's go and do that. You'll need a terminal, and you'll need that key pair that got downloaded. So let me, you need to change the permissions to be read-only before you can access it. And then here it'll show you how to connect with SSH. You say SSH-I private key as your user at blah. So let me do that. And I'll replace this key path with the key path we downloaded. Yes. Okay, so now I've SSH'd into our new VM. And you notice it says, welcome to HSDS for Azure Marketplace. Run sudo HSDS install to install or update the HDS server. So you notice it says install or update. So once you do this install process, if there are any changes subsequent to this, you can always go back and run the same command again. So sudo HSDS install. So to authenticate me, it's asking me to go to Microsoft.com device login. So I will do that. And enter this code. And choose my account. Yes. Okay, so now that I've signed in, this will come back. And it says, welcome. This script will install HSDS. Do you wish to continue? Yes, I do. So you can use an existing resource group or create a new resource group. I'll create a new one because it's just kind of convenient for keeping all the resources related to this together. Let's continue the theme here and call this the HS Demo resource group. And with storage account name, this has to be a globally unique name. So I'll call it JReady HS Demo. So it's creating a storage account. The storage account will contain the containers that store the data that HSDS accesses. Wait a minute for this to happen. And next, which container name would you like to use? So a storage account can contain multiple containers, and let's just use HSDS container for this. Next, it's accessing the HSDS server image from the Azure Container Registry. So note we have either a choice of version 0.6.3, which is our last release version, or the beta version, 0.7 beta 8. So let's go with beta 8, since we're brave. And as the HSDS group releases new versions of HSDS, that will automatically populate on this list. So let's say we have the 0.7 final release. You can go back, run HSDS install, choose that final release, and the server will update to a new version. The logging level is just the kind of tracks the verbosity of the server logs. Info should be fine. And what server name would you like to use? So I'll say, oops, I don't know why it's repeating this. Hello from HSDS for port 80 is typically fine. And what public endpoint? So let's go back here. So if we go to our server, we'll see it's running on this public IP, so I'll want to use that for the public endpoint. You can also have a DNS name, or you could say use Azure Front Door to have a secure HTTPS connection, and then that gets forwarded to the actual server VM. IP in. Next, we can either have a set of usernames and passwords for user accounts managed by the server, or you can use Azure Active Directory. So we'll want to use Azure Active Directory because then you don't need to manually manage those accounts, and it's generally a more secure solution. So yes. Enter the client ID value for the app registration. So this is in Azure Active Directory, you need to create an app registration for the server. And that's described in this documentation link here. I have a pre-created one that I can grab. And if I go here, the app ID should be this, I believe. And next, name of the user will have admin privileges. So I'll just use my account. So the admin user has certain things he can do that normal users can't do. For example, transfer ownership of files or folders, create top-level folders, and so on. Next, you can enter a role for users who have admin privileges. We'll leave that blank for now. And we're done. So it says update configuration, and I say yes. And we say start, I say yes. And now it's pulling the container image from the Azure Container Registry. That'll take a minute. Okay, now it's got the image and starting containers. And you'll see in this case, because of the type of machine we chose, it has 8 virtual CPUs. It created 4 DN containers, 1 SN container, and a rangejet container, which is used to accelerate certain operations. Service is ready. So we can, if we do sudo docker ps, we'll see our set of containers is running. And if I do curl HTTP localhost about, we're sending a request to our server, and it's coming back with a response of like start time, the server state, the name. So here we have hello from HSDS for Azure, and so on. Okay, so next, that's looking good. Let's go and connect to the server from a client, namely my desktop. So we go here, it's larger. So I need to edit this file. So the .hscfg file contains connection settings to talk to HSDS. For one, we have the endpoint, and I think we change that to the IP we have. Oops, that's not it. Back here, IP. And then this app ID, tenant ID, resource ID are all information needed for our HDF client to talk to Azure Active Directory and then get a bearer token that can be exchanged to the server. So let's save that. And now let me create a new Python environment. I'm using Miniconda, but there are other Python environments you can use. Namely, I just wanted to create a separate environment to hold all the Python packages we'll be using. So in this case, I say conda create dash name hs demo Python equals 3.9. Sorry. Create. And next, I want to install h5pyd. h5pyd is the Python package that provides a HDF API to the server and also contains several different tools we'll be using. So I do activate HS demo, and then pip install h5pyd. All right, so now that's installed. I'll also do a pip install of h5py just to read local HDF5 files, which I'll need in a minute. Okay, so now that we have that, we have our hscfg file. I should be able to do hsinfo and get information from the server. Okay, so again, it wants to authenticate me as JReedy, so I'll go here. Create a server locally. Good. Try this again. So hsinfo. Aha, success. So it has the endpoint, my username, the server version, the node count, the uptime, and the h5pyd version. So now we have, we're connected to the server from our client, and it's up and running. It's all good. What content do we have? Well, if I run command hsls, I can see there's a root folder, and that's all there is. Okay, so let's make some content. I will do the command hstouch and /home to be like a home folder. And I'll use the flag -o admin just to denote it's an admin folder and not my personal folder. Okay, now if we do hsls, we see there's a home folder. And furthermore, if we go to Azure, we go to the portal. And storage counts, and then we see the containers. There's the HSDS container. And we'll see, voila, there is a folder here called home, and it contains information particular to that folder. Next, let's create a folder for me personally. So I will do hstouch/home/jready. And now if I do hsls/home, I'll see there is the parent folder /home and a subfolder /home/jready. The owner of this first one is admin, and the second one is jready@asiagroup.org. So that means by default that only my account will be able to create content within that folder. So I can do so like hstouch/home jready foo.h5. This will create a empty HF5 domain. And if I do hsls/home jready, we'll see that there is the foo.h5. And I can do hsls with that and see, oops, we have a root group and nothing else. So that's rather boring. So let's take a more interesting HDF5 file. I have one on my machine called tall.h5. If I run the hdf5 command, h5ls-r tall.h5, I'll see that this file has a root group, a subgroup, a sub-subgroup, a couple of data sets, external link, soft link, another group, and so on. If I want to upload this file to the server, I can run the command hsload, file name, and then the path that I want to see on the server. So let's just do home jready. Okay, so that parsed the file and it's conversing to the server. And now if I do hsls jready, I'll see that content. Okay, so there's my file. If I do hsls h5, we'll see the same hierarchy as before on my local machine. But now this content is being managed in Azure container. And if we go back to here, we will see that if I go to home, jready, there's now a folder called tall.h5. So why a folder and not an object, you might ask? Well, this object just contains information about access privileges and the root ID. The actual ID, which you can see if you do hsls-v, the root group ID is this G-75197CCD, and so on. Okay, this is the ID that will be used to identify this root group. And the actual content for that group is stored in this top level folder called DB 75197. And see here we have subfolders for D and G, datasets and groups. If you examine go for D, you'll see that there is a folder for each dataset. This file happens to contain 4 datasets, so 4 folders. And then each folder will have a JSON that gives them metadata for the dataset, and 1 or more files that store the chunk information. So the dataset, the JSON is JSON data, and the chunk information is binary data. And typically, these chunks are stored like 2 to 4 megabytes each. In this case, it's only 400 bytes because it's a very small example data set. Next, I want to show you about the access permissions. If I do the command hsackle, here we can see that the admin user has permissions to create, read, update, delete, read the ACL, modify the ACL, and similarly, jreedy@hfgroup.org has permissions to do all the above. You can add ACLs to give specific users or groups permissions to do some or all of these actions. In a bit, we'll see how that works. First, let me add our another account here. I'll take this file, and you'll notice that this file doesn't contain any secrets, just the endpoint and these the identifiers for the Azure Active Directory settings. So I can take this and I will share it with our co-presenter here.
Okay, so to get my computer ready, I'm going to install a few things. So pip install h5pyd, and then pip install h5py. And then John messaged me in another window what he just showed on screen. So I'm going to create an hsconfig file, .hscfg, paste in what John sent me, save that. And then to verify my connection, I'll use hsinfo, and it's going to have me log in. So we're going to open this URL. And we'll put in this code. Okay, and we're all set. So the next thing I'm going to do is load a file from my computer here. Downloads, astrojet.h5 into my new home directory. Whoop.
It's no slash and a capital D downloads.
Okay. Sorry, new to Max. And there we go. And then I'll just check it. And there we go.
Awesome. Okay, so I am still connected to the server. I'm logged in as jreedy@hfgroup.org. And you'll note it says admin. That's because I'm one of these special admin users. And if I do hsls/home/story. Now again, these paths aren't paths on my desktop. These are paths that are maintained by HSDS that are ultimately stored in the Azure Blob Storage container. Okay, but we see there's the AstroJet, And if I do HSLS astrojet, so if I go to hsls/home/lori/astrojet.h5, I can see the same content. Now, actually, I can see this because again, I'm an admin user. If we do hsackle, that will show the permissions for this file. And the ACL is that Lori can create, read, update, delete, read the ACL, modify the ACL, while the admin also can do those things, but other users who are logged in would not be able to access the file at all. If we wanted, for example, to let Joe Cool access a file, we could say hsackle /home/lori h5, the permissions, and Joe Cool at hsgroup.org are, we can let everyone have read access by using default sname. So let me add that ACL. So hsackle, and I'll say we want everyone to have read permission for the file itself and read permission for the ACLs. So R for read and E for read ACLs, and use default rather than a specific user or group. Okay, now if I go back and show the ACL again, I see that there's a new ACL called default, and this ACL cannot create new files, it can read the content, it cannot update the content, it cannot delete the content, but it can read the ACL, but it can't modify the ACL. So you can use any combination of permissions that makes sense for your application. So now Lori has been able to upload this file to the server. Let's try accessing the contents using a Jupyter notebook. So here I am at the terminal. If I do hsls/home/lori, I'll see the file she uploaded. And if I do hsls/home/lori astrojet.h5, we see the contents of this file. Now, normally, I wouldn't be able to see her file because I wouldn't have permissions. But because I'm admin, I am able to see her file. If that wasn't the case, she would need to run a command like hsackle to add a permission to the file. And the syntax is hsackle, the file name. And I should say that in HSDS, you always provide the full path name because there's no concept of a current directory inside HSDS. So hsackle, the path name, and then what permission you want to grant, for example, read permission. And then who we're granting it to, in my case, it would be this. And now if we look at the ACLs for the file, we see that there's jreading at hfgroup.org has permission to read the file. It's kind of redundant in this case because it's admin that would always have permissions, but for non-admin users, this would grant them permissions. Now let's create a notebook and kind of visually look at the contents of this file. So I'm going to import h5pyd, numpy, matplotlib, and then we're going to open the file, get a handle to the file. So you say h5pyd.file, the file name. And this syntax is just like would be with h5py and regular HDF5 files. So we have a file handle, and if I list the contents of the file, I see there's 3 objects. Let's get the data set. So the data set equals f bracket data set. And if you see that, we'll observe it's a 3-dimensional file. Dimensions 40 by 40 by 80. And the type is a 4-byte floating point. So let's grab, say, the first slice of this file. So I'll say data equals data set, the first index, and then everything from the next two dimensions. So now we have a NumPy data array. Now you can see the contents here. Now note that in this case, since this is a relatively small data set, it will be no problem to grab all the data at once. But if you had a larger data set, say it was 4,000 by 4,000 by 8,000, then this ability to fetch just a particular slice from the data set is very useful, because that taking larger slices would take a lot of time to download from the server to my desktop. Here, we're able to pick and choose what particular data we want to get. In this case, the first slice of the data. Okay, finally, let's do a little matplotlib image of this. So I'll say plot.imshow the data we got, and say origin equals lower. And we'll see there's a nice image where the values of the data set are colorized. If we say take a different slice, say slice 10, we could rerun this, and now we will be showing a different slice of that 3D data cube. Things like that. So it's kind of interesting, right? You can slice your way through the entire data set, and you could slice in any kind of orthogonality. For example, if I say I want to get everything from the first dimension and this slice 12 from the second dimension or from the third dimension, then we would have a slightly different looking image. All right. Okay, so I hope that intrigues you. I encourage everyone to give this a try. As you can see, it's pretty easy to get going. It'll be very interesting for you guys to try it with your own data. If you have any questions or problems, feel free to contact HR Group at help@hrgroup.org or contact us on the HSCS forum, and we will be happy to help you. Thank you very much.